class on start here. Saturday, 4 to 6. You do. Okay.
4 to 6. How you go record that?
I started at my tap recording a few of the machine. I open class and recording answer the cat.
I don't know.
Yeah.
So why they maybe you can't see?
You see, we did there, we know the monitor if they treated the cheat or not, so if you can't put cancel. I'm in front of pay. Monica Matiko Odonko. Matiko Odonko. I'm friend. For the class rather, we used to defend link here. I didn't class, no, we are enjoying it. I hope for two. No friend, what I mean.
Good evening to you all.
Good evening, sir.
You're welcome.
Thank you, sir.
This edition of our lecture.
Stores. Yeah. Come on, bro. Now you work for stores. Come on, bro. The work for stores. Not sure. Paddy. Bad man be. I was me to the axi and I will bada. More benigina that and get it and can hackle.
My code Digi Campus.
Because sometimes the girls do what it just for do if you sit.
Digi.
Hello, madam. Madam, please, good evening. Madam, please, this is Francis from UC Sukud.
Campus.
Madam, please, I'm calling concerning about our class we have right now. All right, madam. Okay. Okay, right now I'm the only one there.
My code, please mute yourself.
Yes, please. No one has joined. Eunice did join, but she left.
My code.
All right.
Good evening, sir.
Good evening. You are welcome.
Thank you, sir.
Okay. All right. 19 people have joined, so you can start something. Okay. Yeah. Last week we talked about geometric constructions, and today we are looking at circuit theorem. Circle theorem. That is what we are looking at today. Okay. So the circuit theorem, we shall be looking at basis of a circle. Basis of a circle. Then we look at circuit theory 1 and 2, Circuit theorem 3, circuit theorem 4, and 5 and 6. Then 6 and 7, we look at 8, 9, and 10. So by the close of this evening lecture, we should be able to achieve all these objectives. Okay. So by the close of, or by the end of the unit, we should be able to draw a circle and label its parts. We should also be able to explain the various parts of a circle with illustrative examples, and also give at least 4 properties of circle. We should be able to show a step-by-step proof of the fact that the angle a chord subtends at the center of a circle is twice the angle it subtends at the circumference of the circle. Also, to be able to prove at least 4 properties of a circle. Also, to prove that the diameter of a circle subtends at an angle of 90 degrees at the circumference of the circle. We are also proving angles in the same segment are equal, and also opposite angles in a cyclic quadrilateral add up to 180 degrees. We are also proving that the length of 2 tangents from a point to a circle are equal, and also proving that the angle between a tangent and a radius is in a circle is 90 degrees. We should also look at the angle between the tangent and the chord at the point of contact. We shall show the perpendicular from the center bisect a chord. Then finally, we also proving the equal cos that subtends equal angles at the center of a circle. So these are the things, and many of them, that we are looking at. Okay. So let's begin with some basics of a circle. Basics of a circle. Basics of a circle. So this is a circle, and the circle has been, divided in different parts. We should be able to know the parts of a circle. Be able to know the parts of a circle. So how do we describe a circle? I want someone to describe a circle for us. Yeah, Prince.
Say, please, sorry, we can't see your screen. As in,
Is it too small? You can't see at all.
can you enlighten? No, it's half minimized.
Oh.
If you can maximize it for us.
Mm. I'm trying, but you know, check. Mm. Can you see now? Is it okay?
So please, it's minimized. I think the slide showing at the left pane is what is making the screen minimized. So if that can be closed or something.
Okay.
Hello, sir.
Yeah.
Hello, sir. Yeah, I think you should maximize your
Hello.
window. Hello, sir. Instead of increasing the zoom, I think you should maximize your window rather, and that will help.
That's it too. I've maximized it.
That the Windows is already maximized. I think it's from
It's already maximized.
it's from the
Yeah.
laptop, the display,
Mm-hmm.
and so we can continue. Sir.
The display is small, right?
Yes,
Let's
sir.
manage it like this.
Let's manage it. We can continue.
Okay, let me check. Um, all right, let me go and come back. Wait for me, right? The screen is difficult to be shared. So let me restart my system and come back. Is it okay?
Yes.
Yes, sir. It's okay.
Okay, so we want to define a circle. Can someone define a circle for us? Mm-hmm. I am waiting. No. Oh, so nobody. Okay, yeah. Francis.
Okay, so I will say a circle is a two-dimensional shape which every point on the boundary is the same distance from the fixed point or the center.
Okay. That's right. So the fixed point is called the center, and the center is usually denoted by O. So that is a circle. Now the distance from the center of the circle to any part of the circumference is what we term as the radius. So if there are many, we call it radii. If it is singular, it is radius. Okay. So let's move on. So we also have another part of a circle called the diameter. We have the diameter, which is a line dividing the circle into two equal parts. Any line that divides the circle into two equal parts is called a diameter. And a diameter consists of two radii, but they pass through the center of a circle. Then we move on. So we have this. BA, the line BA is a diameter. DC is a diameter. GE is a diameter. FE is also a diameter. It's also a diameter. So let's move on. So any distance around the circle is called the circumference. So circumference is the same as what the perimeter of a circle. A distance around the circle is called the circumference, or the perimeter of a circle is called the circumference. So we are moving on. We also have a chord. Chord is any line segment that connects any 2 points on the circle. Let's look at an example of a chord. This is a chord. This is a chord. The line MN is a chord. It's a line that divides the circle, but it does not divide the circle into two equal parts. It does not divide the circle into two equal parts. So we call it the chord. So the diagram here, MN is a chord. Then we also look at another part of a circle called arc.
Hello, sir.
Arc is a part of the circumference.
Hello,
Hello.
sir.
Preparing the
Sir, please, we
class.
are hearing
Hello.
some feedback. We are hearing some feedbacks. Some people's microphone are on.
People, put your microphone off. All right. So we have an arc. Arc is incomplete circle. Okay. Arc could be small, arc could be big. So a small arc, we call it minor arc. When it is big, we can call it major arc. Then, yeah, so that's it. So let's look at these diagrams. So the line AB is a radius. The line DC is a diameter. The line DE is a chord. And the distance from A to D is an arc, either this way or that way. They are still arcs. Okay. Also from A to C here is also an arc. C to E is also an arc. D to E is also an arc. I hope we all know these things already. So we are only looking, revising. Okay. So we are beginning with the first theorem, theorems 1 and 2. Theorems 1 and 2. Now let's see what the theorem is talking about.
Hello, sir. Please, what about the secant? What is the secant?
Secant. Let me look for it. We have it somewhere. You also have the tangent. I hope you know what the tangent is. All right, someone should tell us what a secant is. James, is your hand up? James, okay. So I should describe a secant for us. So one should describe what a secant.
Hello, sir.
Hello, sir. Because of the network, we cannot hear.
Guys, am I the only one not hearing, or we are all not hearing it?
It's
all not hearing it. Why?
No, we are not hearing it.
We are not hearing basic. We are not hearing.
We are not hearing. No. We are not hearing anything.
Charlie, listen, you got to be for because the guy is off from the TV.
Hey, Mama.
I'm back.
Do something.
He has left.
Hey, today you didn't see me.
Hello.
Yeah. Are you there?
Hello.
I am back.
I think your network is not here now.
So the angle over here.
Yes, sir. So we are here.
All right. The angle A that's subtended at the center is equal to
Sir, the network problem. The network is not good.
Sir, your network is not clear now.
2B.
The network is poor.
Yes, it's very poor.
I'm finding difficult to hear whatever.
Hello.
So A is equal to 2B. So if you want to make B the subject, B also be equal to half of A, or A over 2.
So still.
Is it clear now?
Yeah, for some moment it was.
Yeah, it counts and it goes.
I hope it's okay now. Is it okay?
Yes. Hello.
It's fine now.
Okay. So let's go over the first theorem again. We are saying that any angle subtending at the center of a circle is twice the angle subtending at the circumference. So A, which is subtending at the center of this circle, is equal to 2 times the angle that's subtended at the circumference, which is B. So in other words, B is equal to half of A. Okay. So let's look at these examples. When you come here, the angle which is here, subtended here, should be equal to the angle that's subtended at the circumference. Okay. Now, if you want to find, you actually have to find the variables in the diagram. We have X, Y, Z. The Y's are 2. We have one up here, another one here. That shows that that diagram, that triangle is isosceles because 2 of the base angles are the same. So these 2 diagrams, they have the same, the sides are the same. Okay. So meaning when we add y plus z plus y should give us 180 degrees. Okay. And this one to the same thing. We have w here and x. So w plus s equal to 180 degrees. So 2w plus s 180 degrees. Now let's look at the diagram down there. The same thing is happening. The angle has been subtended at this, the center, which is A, and A should be equal to 2b. A should be equal to 2b. Let's look at the diagram here. Find the values of the variables in the diagram below. So S and Y. What will be the value of X? Mauli, your hand is up. Can we hear you?
Please, it is a mistake.
It's what? Okay.
It's
Then
a
James
mistake.
Akko. Is James on the line? You two, your hands is up. Francis, your hand is up. Emmanuel, your hand is up.
Okay, sir.
Okay.
Please, to find the value of x,
Yeah.
we will first represent the line which passes through. Hello. Yeah, you first find an angle. Okay, let's say this. Let's represent the angle closer to the 142 degrees by B. So we first calculate for the angle B. So since it's a straight line, angle on a straight line is equal to 180 degrees. So we are going to get our B to be 38 degrees. And from our previous objective, yes, we know that angle X is equal to 2 times angle B. So we're going to get X to be 38 times 2, which is 76 degrees.
That's right. You are right. Okay. The angle Y is not clear, so I don't know where they put it. Okay. Let's move on. Yeah. This diagram, what can we say about it? We have the angle at the center, which is 146. Then we have the one that's subtended at the circumference here as x plus 10. Yeah, Francis.
Yeah, so this one we use the same idea. So we know that angle 146 degrees is equal to 2 times the whole of x plus 10. So from there we calculate from the value for the value of x.
Okay. 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 Yeah, so this one also to calculate the x. the value of S. How do we do that? Oh, Francis again. Different persons should do that. I want different person to do that. Mm-hmm. Who is coming? Okay, Francis. Let's go.
Okay, so this part, I think before we can calculate for our x, we need to find an angle which joins the 204 as a circle. So that one, when we are to find this angle where the O is being represented, let's say that angle is equal to angle POR is equal to B. Then we add that angle plus the 204 to get our angle B. So if I subtract 204 from the 360, I'm going to get 156. So we now know that the angle O is 156. And before we can get angle PSR, we say that from the previous idea, 2 times of that angle is equal to the angle POR. So we are going to divide the 156 into 2 to give us 78 degrees. Okay. So now to find x, we have a quadrilateral, and then we know that the quadrilateral, the interior angle sum up to 360.
That's
so
right.
we add everything, then equate it by 360 to find our x.
Okay. That's correct. That's very, very correct. Okay. This diagram, how can we say? You look as if everybody is not interested in this. Only Francis is answering the questions. We have to calculate the angle XZY. XZY, this angle. We have to calculate this angle. XZY, this particular angle. What should we do? Yeah, right.
From the first theory, the 110 will be equal to twice the angle XZY. Hello, sir. So angle XZY will be 55 degrees. Hello. Sir.
Okay.
Hello, sir.
Hello.
Hello, sir.
I think
I
his
think so.
network
Second
again.
network is not.
Hello, sir.
Hello. Huh. Okay, I am now back. Today things will be tough for us, but we shall manage. Tough. Yeah. Who was answering this question?
Yeah, right.
Sir.
Right. What did you get?
Sir. 55 degrees.
55 degrees. 55
Yes,
degrees.
please.
Okay. Let's check if that is correct. Yeah, it's correct. 55 degrees. 55 degrees. Let's move on to the second theory. The second theorem, which is about the diameter. It's about diameter. So the diameter of a circle subtends an angle of 90 degrees at the circumference of the circle. The diameter subtends an angle of 90 degrees at the circumference of a circle. Okay. So these diagrams are, these lines are the diameter. Diameter. Another one here. So any angle that is subtend at the circumference should be 90 degrees. So this angle is 90 degrees. This is also 90 degrees. So that is the second theorem. Very simple as that. Let's look at some examples. Let's look at this diagram. In the figure below, TB touches the circle at B, and BD is a diameter. BD is a diameter. Here is it. Angle TB is equal to 31 degrees, and angle BAC is equal to 69 degrees. Calculate for angle CAD. Angle CAD. This is CAD, this angle. We are calculating for this angle. Now we were told that BD is a diameter. So how do we find that angle? Yeah, so Francis.
So from our theorem that it says that the angle, the diameter subtends at the circumference of the circle is equal to 90 degrees. So if you are finding angle BAD, it means that if we represent the angle BAD by x, we are going to add the x plus 69 to give us 90.
Then you make S the subject. Is that not it?
Yes, please.
That's right.
So S is equal to 21 degrees.
Okay. We are behind time, so we shall be moving a little bit fast. So here, these are the diagrams that we have to find the values of X in the diagrams. Yeah, somebody should speak about the first one, the E, this diagram. Prince.
Yes, sir.
Can we hear you? Let's hear you.
Okay, sir. Please, I don't know if I can share my screen. Okay, so per the first rule.
The first theorem.
Yeah, the first theorem.
Mm-hmm.
So the angle that is suspended at center O is equal to twice the angle that is at the circumference.
Mm-hmm.
So we are going to have 4x plus 40 being equal to 2 into x plus 50.
Okay, it's okay. Now let's do the second one. The second one.
With the second one, we have 194 degrees equal to 2x. And we solve for x.
Okay. What about the third one?
165 degrees is equal to 2x.
All right. Let's move quickly because we are behind time. The diagram below shows a circle PQRS with center C, quadrilateral CPSR is a rhombus. So angle QPC is equal to angle PQR, which is equal to X. And angle PQR is equal to
Please hold on small.
I should go down.
Yeah, this part you're moving faster a little bit, please.
Okay. The diagram below shows a circle PQRS with center C. Quadrilateral CPSR is a rhombus. So this quadrilateral in the circle is a rhombus. So that angle QPC is equal to angle QPR and is equal to X. So we are talking about these two angles. Then angle PQR is equal to Q, small q. You have to find small q.
Please, I say angle PQR is equal to what?
Small q.
Small q.
Small q, okay.
So we are finding that small q. Mm-hmm.
So let me try. Let me try this one.
Okay. Okay.
Uh, with this one, I would say that from our previous theories, I can say that angle PCR. Yeah, no, sorry. I can say that angle PQR, which is small q, is equal to half of angle PCR.
Okay. That's right.
Sir,
Yeah.
I also said that
Mhm.
angle P is equal to twice of angle PQR, which is small q.
Come again.
I said that
Yes.
angle PCR,
Mhm.
which is in the center,
Mhm.
is equal to twice of angle PQR, which is the small q degrees.
Twice that one?
Yes.
No. It should rather be twice angle Q equal to that angle.
Yes.
PCR.
Is equal to twice of angle C.
No. Angle at
So
C.
let me come again.
Okay, come again.
So what you say is that the twice of angle PQR is equal to angle PCR.
Yeah, you are now saying, yeah, that's right. That's right. Okay. Okay, because of time, let's move on to session 3, circuit theorem 3. So the third one is angles in the same segment are equal. Angles in the same segment are equal. I hope you know segments. This area here is a segment. This area down here is segment. This also is also a segment. Another segment can be found here. So angles in the same segment must be equal. So looking at this angle here, we have angle X and angle Y. They are on the same segment. Therefore, they must be equal. Let's look at examples. Looking at this, angle X and angle Y, they lie on the same segment. So they have to be equal. This is a chord, and this area is what? Segment. So these two angles, angle B and angle A, they all lie on the same segment. Therefore, the angle A should be equal to angle B. This is segment. So these two angles up here must also be equal. They must also be equal. So this example. Find the value of the angle Y in the diagram below. When you draw this line here, you draw a line through this from P to Q. You realize that the angle 80 and the angle Y are lying on the same segment. So they should have equal value. So Y should also be equal to 80. Let's look at this one also. A and B, what will be the value of those angles? Someone should do that one for me. I want someone to find the values of A and B. Yeah, Francis.
First of all, I'll first calculate for the value of B using the other rules, using the second theory.
Okay.
I know that angle B is equal to half of the 120.
That's
I think the
right.
other parts are not named, so I couldn't name the angle.
Okay.
So it means the angle B is equal to half of 120, which is 60 degrees.
Okay.
So if I draw a fainted line from where the 40 degrees is to the angle C, I'm going to get a segment.
Okay.
So it means that angle A is equal to B, which is equal to 60 degrees.
That's right. So let's look at that diagram too. Angle ABD, you have to find angle ABD and angle BAC. ABD and BAC. Yes. Francis again. Okay, this time around, Bright's house is up. So let's listen to Bright, my clean.
Right. So using the this one, theory 3, we learned that an angle that is on a segment are equal. So if I should extend the chord from A to D, I would have the angle ACD equal to ABD.
Okay.
And then if I also sustain another chord from B to C,
I can say that angle CDB is equal to CAB.
So what is angle ABD?
ABD, that's 37 to.
Okay. What about angle BAC?
BDC.
It's BAC.
BAC is 53 degrees.
53 degrees. Please, I hope you all understood. Yeah. So he said when we should draw a chord here, this is a segment. Therefore, these two angles must be the same. Angle at B should be equal to 37. If you turn the diagram, this BC is also a chord. So these angles up here are sustained by this what they call a segment. So this 53 and this angle must also be the same. And that is absolutely correct. Okay. Let's move on to theorem 4, 5, and 6. So theorem 4, opposite angles in a cyclic quadrilateral add up to 180 degrees. Then theorem 5, the length of the two tangents from a point to a circle are equal. Then the last one, the angle between tangent and a radius in a circle is 90 degrees. So these are the theorems. These are the theorems. Now let's apply the theorems. So opposite angles in a cyclic quadrilaterals add up to 180 degrees, meaning that this angle here, the angle at A, is opposite to the angle at C. So when you add the two angles, it should be 180 degrees. Angle at D is also opposite to angle at B. When you add the two, it should be 180 degrees. Let's move on. So the same thing is happening here. The whole of this angle should be equal to the whole of this angle. The whole of this angle should also be equal to, the whole of this angle plus this angle should be 180 degrees. This angle plus this angle should also be 180 degrees. All right, work for us. In the figure below, CB touches the circle at B, and BD is a diameter. Angle TB is equal to 31 degrees, and angle B is equal to 69 degrees. We have to calculate angle ABC. ABC, this angle. You have to calculate this angle. Can somebody help? Right.
Right. First is the angle CDA 100 degrees.
Let me check. It's 100.
Okay, so we learned from the fourth theory that
And the other one to 69.
okay, all right.
Okay.
So the angle I'm finding is ABC. So
That's right.
from theory 4, we learned that a quadrilateral, a circular, or how do I put it?
Cyclic.
Opposite angle.
Cyclic quadrilateral, the two opposite sides add up to 180.
That's right.
So yeah, so angle CDA being 100, then it means its opposite angle CBA. We can replace that angle with an x, then equate. So we add 100 plus the x and equate it to 180. Then we find x. So when we do that, x is 80, which is also the same as angle CBA. So angle CBA is 80 degrees.
Angle
CBA.
CBA. Is that what you are finding?
Yes, please. ABC. They said
ABC.
ABC. Sorry,
Okay.
ABC. Yes. ABC.
Yeah. When you add this and that, it will give you 180 degrees. Is that not it?
It should be equal to 180. Yes. Yes, sir.
Okay.
So if let's say we are replacing angle
Okay.
ABC with an X,
That's
then
right.
thank you.
You're welcome. Let's look at this one. In the diagram, not drawn to scale, see the center of the circle, PQRS, STQ, and PCQ are straight lines, and RS is parallel to QP. Angle SPC is equal to 65 degrees. Find angle CRQ. CRQ. Can someone help?
This is the center, right? Hey, sorry.
C is the center, meaning the PQ is a diameter. Okay, Francis.
Okay, so I think since line SR is parallel to line PQ, so it means that angle SPC is equal to angle SRQ. Is that right, sir?
SPC equal to SRC, right?
SRQ.
SRQ. No. Even the diagram itself can also speak for it. Look at the angles, the size of the angles in the two cases. You see that the angle at R is bigger than the one at P. Oh, the ladies, are they not on the the system, have they not joined? I can't hear any lady. Yeah, right.
Say, if we are considering parallel lines, can we also consider the F and the Z angles where we have corresponding co-interior and co?
Corresponding. Why not?
Okay. So I am thinking if I should extend the line S through P downwards, I would then say that angle SPQ, which is 65, and angle RSP are co-interior angles. So they should add up to 180.
Okay.
So I would have the whole of S, the angle find at X as, I will just subtract 65 from 180. Then I'll get that angle. When I get it, I can also extend the line from X through R outwards. I'll again get an F shape. So that angle that I'll get at X plus the one I'll find at would also be co-interior again.
Okay. Let's look at the solution. You have done well.
All right.
So here is it. Angle RCQ is equal to 2 times angle RSQ, which is equal to 2 times 25 degrees, giving us 50. Now, we know alternative angles, like you were saying. Angle SRC should be equal to angle RCQ because they alternate. The sum of opposite angles of a cyclic quadrilateral should give us 180. So we have this. SRQ should be equal to SPQ, which is 180 degrees. Now, when there is a plus here, it did not come. So when you add it to 5 to 8, you get that. And making SRQ the subject, you get 115. So if you want your CRQ, it should be 115 minus 50, which is 65. So please, you have to, okay.
Hello, sir.
Hello.
Sir, based on the question we just saw right now, there's 25. 2 times 25. I want to know where the 25 were. That part I do not understand. I do not get it.
$25. So let's see angle RCQ. RCQ. He said it's twice angle RSQ. Yeah. Let me see. From the question, there's problem with the question.
Yes, sir. Because the 25 degrees was not mentioned in the question.
Yeah. It's not in the question, so there's a problem with the question. Okay, let's move on. We have a lot to do. The length of two tangents from a point to a circle are equal. So these are targets. These lines draw to touch the circles are called tangents. Tangents. You see the length of two tangents from a point to a circle. So these two lines, they are equal. That is theorem 5. Shall we look at theorem 6 also? So theorem 6 says the angle between tangent and radius in a circle is 90 degrees. Angle between tangent and radius is 90 degrees. Absolutely. That is correct. This angle, this is a radius. A to D is a radius. A to B is also a radius. So these two, this angle, because the radius meets the tangent at 90 degrees. They are perpendicular. So they will form an angle of 90 degrees. When you come to this side also, here they also form an angle of 90 degrees. Okay. Let's move on. So let's look at this example. In the diagram below, angle COB is equal to 120 and angle CAB is equal to 60 degrees. CAB over here is not written. This is 60 degrees. Find angle OAC. OAC. And angle OBA. OBA, yeah. As for this one, is the OBA is correct. But this one, the first one is not correct. It should be angle OCA, not OAC. So we have to find these angles. And these angles. Yeah, Francis.
The two of those angles are all equal to 90 degrees. Since they meet the radius, the tangent and the radius meets at the circumference of the circle, which is equal to 90 degrees.
Yeah. So this values they give is just there to scare you. They are only there to scare you. Okay.
Yes, sir.
Yes.
Please, what we just solved right now, what if they give you, they ask you to find the angle at the A? That's BAC.
Angle at A.
Yes, please.
You apply the first theorem. Angle at A, because you know this one.
The 120.
Yeah.
So we'll find the angle BOC first, then we apply to the A, or
yeah, you find this one. Okay. By
Okay.
subtracting 120 from 360.
Okay.
Then you divide by 2 to get your A.
Okay, sir.
Okay. Right.
Sir.
I saw your hand up. James, your hand is also up.
Sir, please, I didn't quite get him when he was explaining this one. He went too fast for me.
He went too fast.
Yes, please. So can you please take it again?
This particular diagram here.
Yes, please.
Oh, okay. So you see, we've learned that when there is a tangent to a circle and a radius, the two will meet at perpendicular, meaning that the angle between them should be 90 degrees. Because look at it, this one will meet this at right angles. That's 90 degrees. This one, this radius also will also meet this one also at the right angle. So 90 degrees. So both angles here are 90 degrees. It doesn't need for any calculation. You got it?
Yes, please.
Good.
Thank you.
Let's look at this one, the angle marked X. What will be the angle marked X? We know this angle. We know these ones to be 90. So what do? We only add of them and equate them to 360. Then you make your X a subject to get your answer. Or you find the angle below here, not certain and the circumference. So it means the first one, the explanation I gave over there is wrong. Let's go there. The explanation I gave here that you will find, this angle, then you divide by 2 to get A. It's wrong, please. It's wrong. So here what you do is, since this is 90, this is also 90. We have 4 interior angles here. And the diagram, when you sum up all the angles in this diagram, should be equal to 360. So 90 plus 120 plus 90 plus the angle at A should be equal to 360 degrees. Then you make this the subject. So the same thing happened here also. Over here. The same thing. The same thing. 90 degrees here, 135 degrees, 90 degrees. We add with the X and it's equal to 360 degrees. Let's move on. There are examples here that you can solve at your free time. Theorem 7. Theorem 7. What is the theorem talking about? Let me find. Angles in the same segment are equal. Angles, it seems we have done that one already. Okay, so the angle between the tangent and the chord at the point of contact is equal to the angle CB. So let's see. Let me look for the theorem. Well, the angle C alpha between the tangent and the chord at the point of contact is equal to the angle CB in the alternate segment. Okay. Mm-hmm. What does that mean? Let's use this example to illustrate that. In the diagram below, A, B, and C are points on a circle with center O. AT is the tangent to the circle at A. AT, yeah, is the tangent to the circle at A. The line DOE is perpendicular to AB. DOE is perpendicular to AB. Yeah. Okay. So line AB is equal to line AC. This is equal to this. And angle TAC is equal to 72. Calculate angle BCA. BCA, this angle. To calculate this angle. That's right. So this is the solution. Let's look at it. Yeah, right.
Sir, please kindly bring the shape LVC.
Can you do what?
It has gone out.
With the diagram?
Yes, the diagram. I mean, sorry.
That is it.
It's not visible at my end. Oh, okay. So what I
Are you
wanted
okay?
to use is not, yeah, I can see it now. But what I wanted to use is not possible. So I think
Okay.
I'll pass. I wanted
Okay.
so if you check sorry, B, E, and then and C coming down, you realize that it created a quadrilateral, but it is not touching the circumference. That won't work. So,
Yeah.
sorry. Yeah.
Okay. So here we were told angle CBA is equal to angle T. Let me adjust the diagram a bit. Okay. So angle CBA equal to angle TAC. Yeah. CBA equal to angle TAC. Yeah. It is they alternate. Can you see that? CBA, this angle, alternate with angle TAC, with this. Look at it. This is Z. It's like a Z. So, okay. This way rather. Sorry. This way. Let me see. Okay. And that should be equal to 72. Meaning this angle and this one must be the same. All right. So the line AB, because we were to line AB is equal to line AC. Meaning this diagram here is an isosceles. If they are isosceles, it means the base angles must be equal. Yeah. So if this is 72, CBA, BCA, BCA should be equal to CBA. So that's it. We have another which we have already learned about. Let's look at theorem. Time is going. Move on to next theorem. Theorem 8, 9, 10. So theorem A says perpendicular from the center bisect a chord. Equal chords of 10 equal angles at the center of a circle. Equal chords of 10 equal angles at the circumference of a circle. Let's move on. There you are. Let's use this one. Oh, sorry. Let's look at theorem 8 first. Good. Perpendicular from the center bisects a chord. So this line bisects this chord. It has divided the chord into 2 equal parts. Therefore, the angle here must be 90. This should also be 90. And the length from here to here should also be the same because the line is perpendicular. It divides this into equal parts. That's the meaning. Let's also look at the theorem 9. These are the chords. AB is a chord. CD is a chord. So they are saying that equal chords subtend equal angles. Since these 2 chords have the same length, so what will happen? Angle AOB and angle COD must be the same. That's what the theorem 9 is saying. Because the chords are the same, they have the same length. They must subtend the same angles at the center. Let's look at theorem 10. Theorem 10 says that equal chords equal cos subtend angles at equal angles at the circumference. That is angle BOA is equal to angle ODC. Let's go and look at the diagram. So these are cos, equal cos. So BO, OC, they are equal. Therefore, they should have the same angles here. Okay. Coming down here, the same thing. The chord AB and this, let me push it forward up small. Good. This is a chord AB. This is a chord DE. They are the same. So they form the same angle up here. The same angle up here. All right. And this angle too must be the same. And this one, it should also be the same. So when you read this place, you understand. So let's look at the example. Find the value, yeah, McLean.
So I want to answer it.
Okay. Let's go.
So first find the triangle RPQ. The interior angle of the total interior angle of the triangle equal 180. So if I have 55 and 80, then I would have to add and then make the angle that is at P. The angle at P should be, if I should say is an X, I'll find 45 degrees. So total interior angle of the triangle is equal to 180. Then we also learned that for sustaining an angle at the circumference is equal. So then if I should get angle QRP as 45, then my angle X is also 45.
That's right. People, do you understand? We are finishing up. So this is the solution. That is the solution. Because the certain on equal cost. Okay. What about this? Yeah, Bright.
Okay, so say we also learned that equal chord sustaining an angle at the center, those angles are equal. And then if they are equal, then I can replace the two angles as X and X. And then angle on a straight line adds up to 180. So I can say 2X plus 50 is equal to 180.
That's right.
Then I'll make X the sum.
Right.
There I'll get 60.
Okay. Okay. Here is it. So if there's any question you can ask, we are done with the unit. Please, I would advise you solve all the examples in the book, in the module. Try as much as possible to solve all of them. and it will do good to you. So if anyone has a question, you can ask. All right. Are we meeting next week on the calendar? Are we meeting?
Yes, please. Where we are meeting.
Okay. Hey, Jennifer, so you are there, and I've never heard of you. You don't speak.
Sir, sir, please, my network was bad. That's why I couldn't talk.
Okay.
You are lying.
The mathematics have made you quiet. Only the guys are talking. Hey, it shall be well.
Okay.
All right, so next week we will meet and do demonstration. So if there is any question, you can ask. Okay. So we'll end it here and continue next week.
Hello, sir.
Yes, Rich.
Hello, sir.
Yeah, Richard, let's see.
I would like to put across my humble plea to those people involved in the class. I think some of them are very good in the mathematics. So if they can put their numbers across, so that some of us who are not all that good in mathematics, so that when we come to class, we can also start speaking. I think some of us were not speaking at all. It took about 2 or 3 people who were constantly speaking on the platform. So I think they can put their numbers across, and then we also join them in 1 or 2 ways so that they can explain things to us better.
Okay. Brothers, you have heard them. You have heard him. Make your number or your numbers available on the platform for them.
Hello, sir.
So that they can also contact
Hello, sir.
you when the need arises. Thank you.
Sir.
Yeah, yeah.
So I would suggest that, yes, I would suggest that if there is any problem anyone is encountering, we have a group. They can put it in the group so that we all deliberate on it. That's all.
Exactly. That's also a nice suggestion. You can do that. Any other? Something you said, please. There is what? Let me look at your some of the comments. Please, is there any group for this course? Oh, yes, we have a group. We have a WhatsApp group. So how do you join? Please give the WhatsApp, what do you call it?
Hello,
link
sir.
to,
I use the link.
you use, how did you get the link?
Our class send it to me and I join.
Oh, okay. Then let them add you to, the group, so that they should help you to join, okay?
Okay, sir.
Yeah, we have a group where we do so many things, so it's better you join. Otherwise, we will leave you behind.
Okay, sir.
Okay. All right. So see you next week. Bye-bye.
Hello.
Hello, Madam Jennifer. Jennifer.
Hey guys, we're sure. You don't stay with the back of things to make it go on. Do we really understand what is going on? Because I think
Hello.
I
Hello.
if I think if we don't understand, we have to say, because if you accept everything else, then probably we will be just in a problem.
That is exactly what I was talking about. It seems some people really understand whatever was going on, and others didn't understand. But because the few who understands everything were talking, were answering the questions, so I also kept running, going,
But
and it is really going to affect some of them.
it'll be bad because I also feel like Sir was supposed to be solving more of the questions for us because he's teaching us to go and teach. So he will show us,
Yeah.
do this, do that, do this. But from the look of things, we are those answering almost all the questions. You get the only confirmation is
One at
that
a time.
we are right.
It's the noise. One at a time, please.
So mostly
Please,
what
one
is
at
the
a
way
time.
forward? Because what is the way
Hello. Please, I've
What
posted
I've
the
seen
link,
is
so you can click on the link.
Please, I'm sure Sir is gone. So we are just discussing as to what we should do. So let's discuss.
Hello.
Everybody can unmute himself. Let's discuss.
I've posted the link. So please, you just click on the link.
If you talk, then you are mute. If not, it is going to be a lot of noise. Please, this is
Colleagues, please
Oh,
let me chip this in.
my first time joining in the class.
Class,
But what I have understood is that
to
it's like what is to cover the period. He wants to cover everything. He doesn't even ask whether
Antoinette,
we are
hello.
or not.
Red, please call her for me.
Please, we are having a conversation. We are having just in a discussion. Let us stick to the discussion, please. Okay, you can speak now.
Please, can I speak? Yeah, I was saying that this is my first time joining this class, and then what I've noticed is that he gave himself a target that he need to complete before he leave within the period. So I think whenever he teaches, he doesn't even ask whether we understand or not. So he's just going. I don't know whether that's how it has always been or it's just this period that he's doing that. What I thought
hello.
is he will teach and then he will ask whether we
Hello.
understand. If you don't understand, then he'll go back.
Yeah, hello.
Yeah, yes, sir.
Well, for me, and I think some other people here, this is not our first time having him as our lecturer. That's how he teaches. Okay, he just brushed through the lesson, but I think the best thing we can do, okay, especially those of us who don't really follow what we are doing, is that just get a time and then go through the model. The model has given a step-by-step breakdown for you to understand all the concepts. So if you study the model very carefully, you see that they have explained all the laws and everything. But Sir is just brushing through how they got the laws and all those things. Sir is just brushing through and all that, just to finish the unit. That's all. So that is it. Just get a time and then go through the model yourself, step by step. That's all. It will help.
Okay, can I
Brother
take one
George,
minute?
Please, can I speak?
Okay, No, you can speak.
Yeah, I think for those of us who have been with him, I think since last semester, I think we decided to at least get ourselves some platform and maybe reschedule our time, maybe within the week. After as we are done with the weekend classes, then we fix a date or maybe a time within the week that will favor us all. Then maybe we'll be going through everything step by step. And I think when we start teaching ourselves, I think that one will be best rather than him just coming out and maybe blushing through. And for that, we cannot blame him. Okay. So I think the best option now is, as we discussed the last semester, I think we have to do something serious this semester.
Let me also
Right
come in
now,
place. Let me also come in place. You know something? I'm the one who asked for the those ones among us who are good in maths to help those who are not good or who are somehow finding some challenges in maths, because I have been following how Sir is teaching now. But I can confidently say that most of us do not really understand up to the level we want, because you could see that it took only 2 or 3 people who were talking or who were trying to answer every question. And once somebody says, this is the answer, then we are good to go. We are all good to go. But we are not only 2 or 3 people here. So I'm of the view that because this thing cost me dearly last semester. Last semester, I didn't find any WhatsApp group to join. In fact, I didn't know where to go. It was my first time. I didn't get any WhatsApp group to join. It took me up to the day before presentation before I got a group to join. And when I joined, I didn't know what they were doing. And then because of that, I couldn't do my presentation. So please, if people can organize yourselves and then give us the WhatsApp link for us to also join, and then we all know what we are doing, it will be good for all of us, please. Thank you.
Nobody
all
can
right,
add you up to
Prince,
the WhatsApp group, okay?
Kingsley.
Yeah, John.
Uh-huh. I think what actually what happened in class is that you see sometimes people know the answer, but just that they just don't want to talk. Maybe they are doing something else. You understand? So if others are not talking, it doesn't necessarily mean they don't understand. Maybe they understand well, perfectly, but just that they don't want to talk. But with your point made, okay, about the group, I think on the timetable, okay, on the timetable, all the links are there. Are you not on the college geometry platform, the WhatsApp platform, watching?
Are you talking about last semester's own or this
No,
semester?
I mean this one, this one.
No. I'm not on any platform this semester.
Hey, but so when you want to join the class, where do you get your links from?
I took it straight from the timetable they gave us and the
Yes,
link
so
they
on the timetable, yes, on the timetable, there is a WhatsApp link
okay.
on it. So when you
Okay.
click on it, okay, it will even take you to
Okay.
a community. So you can look on it and join all the other courses you are offering.
Okay.
You understand?
Okay. Okay.
Uh-huh. So do that. And then with what you said we should in fact learn together and teach each other. Exactly so. That is what we have to be doing. But I don't know. The problem here may be that you see some of us too may be offering other courses that. But okay, well, let's bring our ideas on board. Like Kingsley suggested, we find a
Please, can
day
I
during the
can I
week
say something?
so that yes, Mackley.
Okay, so the thing is, this is my first time joining his class. Okay, I think with Francis, he's in IT class with me. I met him twice already. Uh, I don't know. It's not like we know, but then it's just because I went through the model before coming. That's how come I'm able to.
Exactly,
And
exactly, exactly,
then I
exactly.
feel
That is
like
it.
he really, if we are learning, he's teaching us to teach. Then probably he no. This one day I won't take it. we need to say something because this one
Please,
is too much. And before we have
offering
instructors, we have lecturers at our center who teaches us all these courses, and we don't have to literally join the online thing. But now that they've asked us to join the online, like aside the IT, me, I've not really seen anything yet. Really.
Senior, I think the best we can do is that those of us among us, at least one or two people can, volunteer to at least be in the group, whatever area or unit that we do not or we are finding challenges, we give it to them. At least if we are able to meet once, at least 1 hour every day, every week, 1 hour every week, at least we can do something before our time. Because it is
I
very
think
pathetic that
McLeod can help us with that.
yeah. I saw a guy called McLean, my namesake, also contributing a lot. So he and the other guys who were, on the platform. The fact is that some of us did pure maths in SHS. Some of you also were good in core maths in what do you call SHS. So to those of you, when we come to platform or areas like this, you are good to go. But those people who are not, at least they were average in core mathematics, and some of them who didn't do pure mathematics, they will definitely find some difficulties when it comes to mathematics. And it is a fact. It's a fact.
It's not a problem. So
Because
it's not a problem now.
the fact is that sometimes you can even guess or you can even tell from the concept that the teacher or the lecturer himself sometimes find some areas difficult. They will say, oh, let's move on. Yes.
Yeah. So
So it tells you
so
that we should
let's
sit up.
just find a day.
So
That's
I am
all.
not blaming
So
I am not blaming the lecturer. I am not blaming the lecturer. I don't want to put my burden on the lecturer. What I'm saying is that some of our friends should be able to help us. That's all.
that's all. Yes. So as for the lecture there, that is his style. That's it. That one there, that's his style. We have to accept it. So let's
Yes.
just find a day within the week. That's all. A
All
day
right. So
within the week. So that
AJ, I think you people should organize. For now, I'm not on the platform, so I'm going to join the platform any month from now, and then we'll start from there.
yes, I think even Kingsley has even posted the link here in the chat.
Okay.
So you can join from here.
Okay.
Uh, so do that.
Thank you, Master.
So which day do you suggest, as we are saying? Which day?
No, it should be on the one who is going to help us. We cannot suggest a day whilst the one who is coming to help us wouldn't be free. So I think he should tell us today or this day that I'm going to be free, so that we all rally behind him.
But you see, mathematics is very broad, and as you said, as you said right now, that maybe some people were just participating. You see, Brother John also made a suggestion, whereas some people were just not choosing not to talk. Okay, so if right now we just say that if the person who wishes to maybe take the lead or help us, I don't think anybody is just going to feel like, yes, for me, I'm demoting myself to do this kind of task. So let's take our time on this thing, okay? And after we
Exactly.
digest it very well, we can just arrive at a very calm, maybe plan. So let's just relax ourselves, okay?
Exactly. So
Okay.
right now we are not trying to.
Right now, I
We are
can
not
be a
trying to.
volunteer.
Francis, you said.
I said I can be a volunteer.
Okay, so no problem. So you just give a day.
Oh, I'm always available, so the majority should choose a day so that we all can meet.
So since within the week we all go to work, I think probably the meeting will surely be in the evenings. So yes. So any day within the week in the evening, it's okay. I
Okay,
think
so
Monday, for instance, I don't
the
know for
time that we
others. I don't know for instance, but um, tomorrow Monday we have physics. I'm sorry, Monday we have physics in the evening. And Tuesday also, I don't know for now if we'll have any class. But Wednesday, Thursday is free. I don't know for others.
For us, all
For Tuesday, for
Wednesday,
Tuesday
Thursday
we'll
is
be
okay.
having English language. I don't know if
Uh-huh.
there will be another reschedule. So, but let's not rush ourselves, okay? I think after we all
Wednesday.
migrate to the main platform, we can discuss on that.
Yeah. So so that is it. So
So,
just as we have said, okay, from the beginning, just as we have said,
Okay.
on the platform we are going to put a day because set is also on the platform. So let's just put a day there, okay? Wednesday, Thursday, Friday. So when the time is given, if you are available, you can join, fine. I think that will help. That's all.
Okay.
Uh,
Okay.
I
Thank you,
think
colleagues.
yeah. So maybe we should put a poll there. So maybe we vote. So maybe Wednesday, Thursday, or the rest of the days which will be
yeah,
available.
yeah. So that is it.
Okay.
Okay, then
So
we'll meet in
so
the
for
middle.
now we are going to relax because I think we haven't taken the other courses yet. Tomorrow we'll continue. So we'll see if they don't schedule any class on Wednesday, Thursday, Friday. Then we too we can come in and then put our class there.
I have a question.
Yeah.
Please, concerning the class, some of the classes rescheduling to the weekdays. I don't know whether it is only we that we are offering what do you call mathematics IT. I can see that all my courses are within the weekend, and the English language is in the weekend. So I'm surprised Kingsley was saying Tuesday. I don't know whether
we move, yeah. But you see, I think last week when it was time for us to have the English class, I think the madam made it clear that during that particular day, which is Sunday, during that same time, she will be handling a class. Okay, she is having a class from 7. From there, she'll be having another class from 11, from 9. Then ours will be starting, I think, was it from 11:30 or something like that.
yeah,
Then she made it
11:30.
clear that yes, from then to she'll be having another class. So it's just going to be continuous from 7 a.m. So like is it 1 p.m. And you see,
Yeah, I quite
we
remember that was just reading everything for us. She was very tired.
yes. So I think unless tomorrow that we can just verify if
Exactly.
things are going to
Exactly.
change or yeah. So please,
Exactly.
as
Uh-huh.
Brother John said, let's wait till tomorrow.
Uh-huh. Exactly. All right.
All right, colleagues. Thank you very much. I think we'll continue our conversation from tomorrow.